Hello everyone, today we will be going over Geometry Chapter 2, Section 5 of the Big Ideas Common Core High School textbook. So our topic for today is proving statements about segments and angles, and our essential question is how can you prove a mathematical statement? So we're introduced with a new core concept, and that is a proof, which is a logical argument that uses deductive reasoning to show that a statement is true. So below right here, this is what a typical proof looks like. On the left-hand side, we have all of our statements, which are based on facts that you know or are from a conclusion based off of deductive reasoning. The number of statements will often vary in different problems. The number for the proof should correspond with the number of the reason. So on the right-hand side, we put all our reasons, which usually starts off with what is given. Then we can use definitions, postulates, or proven theorems, which will allow you to state the corresponding reason to the statement. And make sure you go step by step so you don't skip any steps, as you will be often marked off for this. So here are some more theorems. Theorem 2.1 is properties of segment congruence. And this one is segment congruence is reflexive, symmetric, and transitive. And here are all the properties. And then we also have Theorem 2.2, which is properties of angle congruence, showing that angle congruence can be reflexive, symmetric, and transitive. So these two are very similar. This one is just dealing with segments, while this one is just dealing with angles. So these basically are the same. You can just replace it with segment and angles. Just make sure when you're writing out theorem, you label it as a segment or a theorem. So as we can see, reflexive is an example right here is segment AB is congruent to segment AB. Symmetric would be segment AB is congruent to CD, which means that segment CD is congruent to AB, so it's kind of flip-flopped. And then finally for transitive, segment AB is congruent to CD, and segment CD is congruent to EF, which means that segment AB is congruent to EF. So here's our first exercise, and based off of the theorems that we just learned, pause the video and try this out yourself. So name the property that illustrates the statement. So for A, if angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R. And then for B, if segment JL is congruent to YZ, then segment YZ is congruent to JL. And this should just be ringing a bell how this is talking about angles and this is talking about segments. So here are your answers. A is transitive property of angle congruence, and B is symmetric property of segment congruence. So here's an example of a proof. So we have to write a 2-column proof for the symmetric property of segment congruence. So what we're doing is just proving this theorem. So we're given that segment LM is congruent to segment NP, and we need to prove that segment NP is congruent to LM. And this proof statement should always be the last statement that you see in your proof. So this is a visual representation of what we know. So we always write what we're given with first. After we do this, we can see that LM equals NP according to the definition of congruent segments. Then we can also deduce that NP is equal to LM by the symmetric property of equality. And finally, segment NP is congruent to segment LM based off of the definition of congruent segments. So here's another example proof. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM and AM is 1/2 AB. So we're given that M is the midpoint of segment AB, so we list that as first. Then based off of the definition of our midpoint, we can see that segment AM is congruent to MB. Next, by the definition of congruent segments, we can see that AM equals MB. From segment addition postulate, we can see that AM plus MB equals AB. Substitution property of equality allows us to add AM plus AM, which equals AB. Distributive property shows that 2AM equals AB. And finally, the division property of equality is AM equals 1/2 of AB. And this is our final proven statements that we have shown below here. So now we have another exercise. Please pause the video and do this yourself and try filling it in, and then I will go over it shortly. So we are given that PQ equals RS, and we need to prove that PR right here equals QS. So what we do first is write given. Given should go right in number 1. Then we can see that PQ plus QR equals RS plus QR, and this will be your addition property of equality. For number 3, we want to use PQ plus QR equals PR, as this is segment addition postulate. This one is already filled out, where the segment addition postulate again shows that RS plus QR equals QS. And finally, we can use the transitive property of equality to show that PR equals QS, which is the final statement. Please pause the video and do all these on your own. What you want to do here is find the property of congruence, whether it be angle or segment congruence, and if it's transitive, reflexive, or symmetric. So number 5 should be the transitive property of segment congruence. 6 is reflexive property of angle congruence. 7 is symmetric property of angle congruence. 8 is reflexive property of segment congruence. 9 is symmetric property of segment congruence. And finally, 10 is transitive property of angle congruence. So in the diagram, segment MN is congruent to segment LQ, and segment LQ is congruent to segment PN. Describe and correct the error in the reasoning. Please pause the video and I will go over it shortly. So the reason this is wrong is that the transitive property of segment congruence, which is Theorem 2.1, should have been used instead of the reflexive property of segment congruence, which, although it is under the same theorem, the reflexive property of segment congruence and the transitive property are completely different. This is because if MN is congruent to LQ and LQ is congruent to PN, then MN is congruent to PN, and this is by the transitive property of segment congruence. So finally, in the sculpture shown, angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Classify the triangle and justify your answer. So the triangle is an equilateral / equiangular triangle. By the transitive property of angle congruence, Theorem 2.2, since angle 1 is congruent to angle 2, you know that angle 1 is also congruent to angle 3, because 2 is also congruent to angle 3. Because all 3 angles are congruent, they all have the same angles, which is the definition of an equiangular triangle. You can also classify this triangle as equilateral or acute. Please like and subscribe if this video was helpful and you want more content on the following geometry chapters. Thank you.